Hello everyone, I'm Raza Kayani. In today's lesson, I'm going to talk about Hooke's law. You are watching revision series of high school physics. At the end of the lesson, I'm going to explain and solve some interesting exam questions related to Hooke's law. First of all, I'm going to talk about learning objectives. By the end of the lesson, you should be able to state Hooke's law and recall the use of the expression F equals to Kx. You will be able to recognize the importance of limit of proportionality for extension load graph. You will be able to state difference between elastic and inelastic deformation. At the end, we are going to calculate the spring constant K from the extension load graph of the Hooke's law. Here's the list of some keywords used in the lesson. These keywords will give you confidence to link the unknown terms with the known one. The known terms in the list will help the student to boost the learning process. In this lesson, we are going to calculate the extension of the material. We are going to use the principle of mechanics and use of Hooke's law in mechanics. We are going to see the elastic limit of different materials. We are going to talk about elastic strain energy stored in the spring. We are going to talk about limit of proportionality, deformation of the material, elastic, inelastic behavior of the material. Now, I'm going to talk about what is the use of Hooke's law. How is Hooke's law used in everyday life? Hooke's law is important because it helps us to understand how a stretchy object will behave when it is stretched or compressed. Springs are also used in children's toy for many years, and they are important to the toy industry long before electronic toys. Hooke's law deals to our everyday lives. We use cars every day, and the shock absorber spring keep the ride smooth. Without these shock absorber, the journey will be very uncomfortable. Hooke's law is widely used in all branches of science and engineering, and in the foundation of many discipline courses in the universities. It also obeys the fundamental principle behind the spring scale, the manometer, and the balance wheel of the mechanical clock work in accordance with the Hooke's law. Now we are going to see what is the relationship between force and extension. In Hooke's law, the force is proportional to extension when material is stretched. This means that the extension of a material increases linearly when the amount of the force applied. The increase in length of spring or a wire by attaching a load is called extension. Extension produced in the spring, a rope, or a wire is the difference between the stretch length and the original length. Till here is the original length of the spring without applying the force. If we apply the force on it and pull to this side, so that is the stretched form of the spring. So we can calculate the difference by using the relationship of stretched length minus unstretched one. If unstretched length of the spring, that is 15 centimeter, and if the stretch length of the spring is 20 centimeter, so in that case, extension will be equals to 5 centimeters. After explaining extension, I'm going to talk about Hooke's law. Materials that obey Hooke's law are called the Hookean materials. So we can say that springs behave like Hookean materials. Hooke's law can be applied to many things in everyday life. Hooke's law is used in mechanics and in physics. It was discovered by English scientist Robert Hooke in 1660. The stretching force in a material is directly proportional to the extension till elastic limit. This relationship is true only till elastic limit. So according to definition of Hooke's law, that stretching force is directly proportional to the extension we can represent this mathematically. F is directly proportional to extension. So whenever we change proportionality into equality, always we write one constant. So in that case, the constant is K. So F equals to Kx is the formula for the Hooke's law, where K is constant known as spring constant, X is extension in millimeter, centimeters, or meters, but SI unit is meters. F is the force or load in newtons. The value of the hook is different for different materials. If the wire spring is made with the steel, with the copper, with the brass, with any other material, so the value of the K will be different in that cases. To perform Hooke's law, we take a spring without load. We take a retort stand. We take a ruler that should be vertical. We use different boss and clamp to hold the ruler and spring. So first of all, with the help of the ruler, we try to calculate the original length of the spring. So we can find the length of the spring by using the ruler in centimeters. That is the original length of the spring. We can record the original length of the spring, say 15 centimeter. And after adding the load to the spring is going to stretch. Initially, we are going to start with 0, 1, 2, 3, and 4 newtons load. By attaching the load each time, the spring is going to extend. If by adding 1 newton, the length of the spring is 16 centimeter, and by adding 2 newtons, 17, 18, and 19 centimeter, by adding 4 newtons, then we can calculate the extension of the spring. So initially, the load is 0, so 15 minus 15, that's going to be 0. So extension will be 0 for the 0 newtons load. But in case of 1 newton, 16 minus 15, the extension is going to be 1 centimeter. In case of 2 newtons load, the extension is going to be 2 centimeters, because 17 minus 15 is going to be 2 newtons. And for 3 newtons, the extension will be 3 centimeters. Similarly, for 4 newtons, the length of the spring will be 19 centimeters, so the extension will be 4 newtons in this case. Hooke's law is also used in other everyday objects, such as trampolines, where Hooke's law is applied when the springs that hold up the center of the trampoline all stretch when a person jumps on the trampoline. When a load is hung from the steel wire or from a spring, the load is increased. The length of the wire increases until the limit of proportionality is reached. If the extension of the wire of a spring increases with greater rate by adding load, then the spring is no longer obeys Hooke's law. Hooke's law shows linear relationship till elastic limit. The graph shows an ideal Hooke's law for spring or for any other material if there is a straight line from the origin. The slope of the line is called the spring constant. The object obeys Hooke's law till here. After that, it starts deforming. Till here, the gradient is straight and constant. That is called spring constant. Similarly, that is the extension load graph. In that case, the graph starts bending after limit of proportionality. So in that region, the material is not obeying Hooke's law. It is behaving elastic. It is behaving inelastically. So we can see the difference between both. How can we calculate the value of the K in that cases? Now I'm going to explain you how to get the spring constant from the graph. In this case, there is a load extension graph. So in load extension graph, the value of the K simply you can calculate by using K equals y2 minus y1 over x2 minus x1. But in case of extension load graph, the load is given on x-axis and extension is given on y-axis. In that case, the value of the K is an inverse gradient. So in that case, m, the slope, so in that case, the slope of the graph will be 1 over K. So the gradient of the graph can be calculated by using x2 minus x1 over y2 minus y1 to calculate the value of the K in newtons per centimeter or in newtons per meter. In this region, after limit of proportionality reached, the graph shows inelastic behavior of the material, which is also known as inelastic deformation. So we can divide the region into two, so that the first region that behaves elastically and that region is behaving inelastically. Similarly, we can see the two regions over here, the elastic behavior and inelastic behavior of the graph. In the above graph, load is independent variable and extension is dependent variable, so Hooke's law can also be defined as the extension in a material is directly proportional to the load if the elastic limit does not reach. So in that case, we can write that extension x is directly proportional to the force. As load is independent variable, in that case, the gradient in this case will be inverse. So x, whenever we change proportionality into equality, always we write one constant. But in this case, the constant will be 1 over K times F. By cross multiplication, F equals to Kx. Again, the equation of the Hooke's law. So we have to see carefully. Before we calculate the value of the K, whether the load is given along x-axis or along y-axis. To explain the relationship between load and extension, I'm going to solve this question. So, objects with different masses are hung on a spring. The diagram shows how much the spring stretches. The extension of the spring is directly proportional to the mass hung on it. What is the mass of the object M? 10 centimeter is the original length of the spring without any load. And 20 centimeter is by adding 100 gram and 30 centimeter by adding unknown mass. The question is, objects with different masses are hung on a spring. The diagram shows how much the spring stretches. The extension of the spring is directly proportional to the mass hung on it. So what is the mass of the object M? As they say, it is directly proportional, so we can use a directly proportional method to calculate. In that case, what is the extension in this case? So the stretch length, the stretch spring after adding 100 gram is 20 centimeter. So the extension will be 20 minus 10, that's equals to 10 centimeters. In second case, by adding mass M, the length of the spring is 30. Okay, so the second extension we can calculate 30. What is the unstretched length? That is 10. So 30 minus 10. So the second value of the extension is 20 centimeters. So we can use this proportion method to calculate unknown mass M. For 100 gram mass, the extension is 10 centimeters. And for M, unknown mass, the extension is 20 centimeters. We can cross multiply to get the value of M. So M times 10, 10M equals 100 times 20. To calculate the value, 100 times 20 divided by 10. 0 can be cancelled by the 0, and we are going to get only 200 gram. That is the mass of the unknown mass. Now I'm going to talk about the limit of proportionality. A spring or any other material is said to behave elastically if once the load is removed, the spring returns to its original length. This is called elastic behavior of a material. So limit of proportionality can be defined as the maximum force that can be applied to a body without producing a permanent deformation in its shape or size is known as limit of proportionality. Inelastic behavior of the material. If the spring is permanently deformed by adding the load, then it will not return to its original size and shape when the load is removed. Hooke's law is not obeyed during inelastic behavior of the material. In these figures, both spring has been deformed after removing the load. If this material will not go back to the original position after removing the load, it behaves inelastically. And the value, as the extension is given along y-axis, and the value of the load is given along x-axis. So the extension 1.41 centimeter, here's a 1.4 centimeter extension. We can pull it on x-axis to calculate the load when the spring is going to extend 1.4 centimeters. That is 3.5 newtons. So the value of the weight of the object will be 3.5 newtons in this case. Now we are going to practice another question. The diagram shows a spring and a graph of the length of the spring against the load applied to it. What is the length of the spring? What is the extension of the spring when a load of 40 newtons is applied to it? So here are two things are asked. What is the length of the spring? And the second thing is, what is the extension of the spring? So first of all, we are going to see the length of the spring. The length with extension is given along y-axis, and the load is given along x-axis. So here is a 1 centimeter, 2 centimeter, and 2.5 centimeter. So this is the length of the spring. .5 centimeters. Now, to calculate what is the extension of the spring when the load of 40 Newton is applied to it. So here's a load of 40 newtons. Till this region is the length of the spring without any load, with 0 newtons. So that length basically is with 0 newtons, that is 2.5 centimeters. Now we are going to see, by applying the load of 40 newtons, what will happen to the extension. So now we are going to find this length basically. So what is the extension of the spring when a load of 40 newtons is applied? So extension equals to 4 minus 2.5. That equals to 1.5 centimeters. So the spring will extend only 1.5 centimeters by applying the force of 40 newtons to the spring. Now we are going to do the last question, where I'm going to calculate the value of the spring constant by plotting the graph. A student investigated the stretching of a spring by hanging various weights from it and measuring the corresponding extensions. The results are shown below. On the graph below, plot the points from these results. Do not draw a line through the point yet. So we are going to, that's the data given for the force and extension. And that one we are going to plot on the graph. So we are going to use load, weight, and extension to plot the graph. So at 0 newtons, the extension is 0. So at load of 1 newton, the extension is 21 millimeter. So here's 20. And that's the 21, according to the graph. At 2 newtons, the extension is 40 millimeters. At 2 newtons, the extension will be 40 millimeters. At 3, it will be 51. Between 40 and 50, there is a 50. So it's a 51. It will be in the middle here. At 4 newtons, the extension will be 82 millimeters. Here's 4. And that's the 80. At 5, it's 103. So here's 100 and 103. So these are the points that we have according to given data. Now we are going to see what is asked in the question. If I'm going to plot the graph of it, straight line graph, from the origin till that point. So it's passing through 1, 2, 3, and 4 points. Okay, now they said the student appears to have made an error in the recording one of the result. So if we see the above result, yeah, he made an error at the third value, that is 3 newtons, that is 51 millimeter. That should be 60 millimeter according to the data. So that was the error. Now, ignoring the incorrect result, draw the best straight line through the remaining points. I already had drawn the straight line passing through the origin through 4 points. State and explain whether this spring is obeying Hooke's law. Yes, the graph is passing through the origin, so it obeys the Hooke's law. So what I wrote here, a straight line is passing through the origin with a constant slope. The slope was constant. It means the force is directly proportional to the extension, so it obeys Hooke's law. Thank you for watching. Subscribe to the channel to receive the new topics.